So we've got these two solutions, and they're pretty amazing solutions. And now let me explain to you why they're amazing and what they can do, what they can take place of. Let's talk first of all to get a little brief understanding of what is typically used right now, okay, in cleaning. If I want to sterilize, excuse me, if I want to sterilize water, what typically is used? What are the methods of sterilization that they use right now? Chlorine, okay. So hypochlorite is basically oxygen and chlorine, right? We take hypochlorite, we put it in water, and it's a fantastic oxidizer. It kills germs, it bleaches things because it's an oxidizer. It was invented by a Swedish guy, I believe in the 1800s. Wow, all of a sudden you took things like cryptosporidium and all these diseases and cholera and that were in the water that massive amounts of people were dying from by drinking impure, stagnated, putrescent, filthy, nasty, disgusting water. Thousands of people were dying. Mortality rate in children was just as high in some places as 6 out of 10, right? So this guy invents this stuff. All of a sudden they start using this hypochlorite, and it becomes the basis, the standard, the world standard for purification of water. Because this right here kills a lot of the pathogens and bacteria in water. So it's been around a long time, and it is a tremendous, like I said, tremendous oxidizer. So if it's that great, then why would we have a need to look at something else? Well, the reason why we would have a need to look at something else is because as good as that is, as amazing as that hypochlorite is, it comes with a lot of negative side effects. So let's just talk a little bit about what some of those problems are using the OCl or the hypochlorite. One is has anyone here ever cleaned a bathroom with bleach? Okay. No. Yeah. Have you made the mistake that I made of closing the bathroom door and forgetting to turn on the fan?
Yes.
Okay. What happens when you're in a small confined area and you're using a bleach product and you're cleaning?
You're choking, your eyes burn.
Eyes are burning. It's incredibly toxic. It affects your mucous membranes in your lungs, actually sears them and burns them and can cause scarring. It makes them constrict so you can't see. It damages the mucous membranes in your eyes. So not only does it have inhalation issues, it can also damage your skin. It is toxic. If you read the directions on the bleach bottle, it says to use rubber gloves. It says to use in a well-ventilated area or use protective things, right? We call these personal protective equipment. So you have to wear a respirator, usually a charcoal respirator. We know that in that condition that if you mix it with other things, like say something like any ammonia-based product, what happens? Boom, right? You mix ammonia with hypochlorite, you create an explosive, potentially very dangerous situation. So phenomenal results, save millions and millions of people's lives. It's basically the standard for the world today. But there's been advances, and I'm going to go over how our product, which is HOCl, very, very similar to this. This has got some negative side effects. This, as far as I know, and in the last 10 years, has no negative side effects. It is as natural a product as you can get. It's as natural as water. So, again, this can be made as a gas. Now, if it's made as a gas, does anyone remember in history class there used to be a gas that they used in the war, First World War specifically? Remember?
Mustard gas.
Mustard gas. What's the primary ingredient of mustard gas?
Chlorine gas.
Chlorine. Exactly. But let's talk about now we put it in water. When you put it in water, yes, it kills a lot of viruses and pathogens, but it doesn't completely destroy them. There's things called trihalomethanes that are left in water, okay, that are basically partially dissolved bacteria that your body can actually capture. And there's been an increase of gastrointestinal cancer since the use of this by over 300%. So again, there's phenomenal success with helping to keep people alive and oxidizing different bacteria. But a lot of other problems have come with that success. So let's now talk about the hypochlorous acid. One, it is a sterilizer, which means that it's an oxidizer, which means that it can kill bacteria, kill pathogens, and kill viruses. So let's just talk. We know about the negative side effects, and we only touched on a few of them. I could spend hours talking about the negative side effects of hypochlorite bleach. But I just want you to know a few things about it. These are things that you could share with people. These are things that everyone's taken a whiff of chlorine. And everyone that's taken a whiff of chlorine is like, right? So that's something that when you talk to someone, it's something they can instantly, they've got cognitive memory of, right? HOCl, on the other hand, doesn't have those same things. It does have chlorine in it, but it's a different species of chlorine. And in this configuration right here, it is safe and natural to use. Now, when I say safe and natural, I mean safe and natural. I don't mean non-toxic. We, at this point, due to the licensing that we have, cannot use that word. You can give it to an animal. We've used it in human consumption for purification of water. There's a tremendous amount of documentation and backup literature to allow a person to come to their own conclusion that it's non-toxic. So the verbiage that we use when we're talking to people today, it is safe and natural. Safe and natural. So what can it be used for? Okay, well, first of all, we know that it is good for oxidizing. So let's just talk a little bit about bacteria right now. This is a cell. Okay, this right here is the nucleus of the cell, right? This cell is usually surrounded in a solution. Most of the time it's an aqueous solution or partially aqueous. Okay, it could be in your blood, could be whatever. Okay, so when the HOCl comes across here, there's a change that happens in here. And the HOCl, what it does is it disrupts the membrane of the cell rather than trying to dissolve it where it can, the hypochlorite acid, it doesn't always kill the bacteria, and it allows for certain types of bacteria to create resistant strains. One of them we know, what's this?
MRSA.
MRSA. That's methicillin-resistant Staphylococcus aureus. Okay, you find that in a lot of hospitals, and they say that it's due to the overuse of antibiotics. The problem is a lot of the cleaning solutions, such as hypochlorite, does not fully kill this. What it does is it'll kill a bunch of it, but then this develops a resistant strain to that. When hypochlorous acid is used, it cannot, will not, and does not develop a resistant strain. The hypochlorous acid comes by it, it creates, through osmosis, it creates an electrical current that this one picks up. As it goes through, it literally dissolves this area, right? When that dissolving in the cell wall happens, the fluid that's inside that keeps the cell alive actually is expelled. Now when that happens, it's instantaneous death to the bacteria, to the cell. This right here is huge. This is probably, if you understand anything that I tell you today, this is probably one of the most important things. Now, that's important for one reason. The biggest reason that is important is because this is the same product that your body makes through an enzymatic change. And because it kills all known viruses, pathogens, and bacteria, things like that, there's really no need for anything else to cleanse. If you've got one product that can kill all known viruses, pathogens, bacterias, depending on how it's applied and how it's used, and we're going to go into that in a few minutes, then why on earth would you want to use things like OCL, hypochlorite acid, or chlorine gases, or any number of any other chemicals that are out there that are toxic, that are corrosive, that have inhalation warnings and hazards, right? That are dangerous to your eyes, dangerous to your skin. You know, what happens if, let's say, I mean, I can go to a cabinet in a restaurant or a house or a kitchen and open their cabinet, and you open it up and you look at all the chemicals. Well, what if you could take all of those chemicals that are hazardous, that are dangerous, that any combination of which could be very, very serious, and get rid of all of those things, and now have something as simple and as safe as this, and it's as natural as this, and this is water.